Good morning, folks. Hope you're having a wonderful day. Today is the most wonderful time of the year because it is May 10th, and May 10th is 510, Sec 510 Day. And I'm looking forward to sharing some of the content that we cover in Sec 510, as well as a little bit more in today's webcast, The Myth of Cloud Agnosticism, Why Securing Multiple Clouds Using Terraform is Harder Than You Think. So today we're going to first off set the stage and explain what Terraform is. Then we're going to explain what cloud agnosticism is. And then we're going to challenge the commonly believed statement that Terraform is cloud agnostic. Then I'll leave you with some additional resources and we'll have a Q&A. So first off, what is Terraform? So Terraform is a tool from HashiCorp, which is vendor agnostic. And that's a term that is commonly used regarding Terraform, meaning that it works with a variety of different services, which it does. You can use Terraform to configure AWS, Google Cloud, Azure, as well as things not in the cloud and different services. Now, Terraform is typically going to be used in multi-cloud environments. If you want to deploy infrastructure to all three cloud providers, you're going to likely use a tool like Terraform because it allows you to write code that defines your infrastructure. This has many different benefits, such as allowing for your developers and your security folks to go through proper change control and code review, as well as you can look at the code and be able to show an auditor exactly what is in your environment. And typically, you're going to be deploying Terraform through your continuous integration and continuous deployment CI/CD pipeline, whether that's in the cloud, like AWS Code Pipeline or similar services, or if it's going to be in something like Jenkins or TeamCity. We're not going to talk about CI/CD in this particular module, but be aware that that's the typical way in which Terraform is deployed because it allows us to give those very powerful permissions to the CI/CD pipeline instead of giving them to individuals. Now, what is cloud agnosticism? Cloud agnosticism, in terms of what VMware defines it, refers to a cloud design strategy in which applications, tools, and services are designed to migrate seamlessly between multiple cloud providers or between on-premises and cloud in a hybrid cloud model without disruption of service. So basically, that means that we can take our application and move it from one cloud provider to another in a way that does not break anything. And cloud agnostic applications should theoretically operate properly, even if they are unaware of the cloud provider on which they are running. They don't need to care about what cloud provider they are on. And this is a reference to the concept of agnosticism in general, which according to Encyclopedia Britannica is the doctrine that humans cannot know of the existence of anything beyond the phenomena of their experience. So just take the word humans in that sentence and replace it with workloads or applications, and you get the idea. The application should not know of anything outside of itself, including what cloud provider it's on. Now, given those statements, we can create a logical syllogism that says that Terraform should have the ability to allow us to migrate from one provider to another seamlessly. Statement one, if Terraform is considered a cloud agnostic technology, which HashiCorp says. Statement two, cloud agnostic tools can migrate seamlessly between multiple cloud platforms. That leads us to the logical conclusion that Terraform can migrate seamlessly between multiple cloud providers, or it can at least enable us to migrate from one cloud provider to another. Now, is Terraform really cloud agnostic? The answer is not exactly. Now, why is that? If everybody calls Terraform cloud agnostic, Terraform calls themselves cloud agnostic, everybody calls Terraform cloud agnostic. And this was a conversation that I had at a previous SANS event. And what really inspired me to give this talk is that people thought that it could solve the problem of multi-cloud, the problem of having multiple cloud providers. When in reality, Terraform may be a helpful tool to use in those environments, but it is not a solution to the multi-cloud problem. So why? Well, to understand this, let's take a look at some Terraform syntax Terraform uses the HashiCorp language, or HCL. And for those who think that Terraform enables us to solve the multi-cloud problem, I think that they imagine that Terraform looks something like this. We would want to create a storage bucket. We want to give it a particular name, such as assets. And then we want to target AWS, Azure, and GCP and say that this bucket is private. That would be really ideal because it would mean that we could deploy a consistent bucket consistently across all three cloud providers, of the big three cloud providers, I should say. Unfortunately, that is not the case because while Terraform itself is an agnostic platform, it leverages providers that are specific to each cloud provider. I'll explain what that means in just a moment. Fundamentally, cloud infrastructure often includes highly specific services and platforms. So most of you are familiar with Amazon Simple Storage Service, or S3, and the analogous services, Azure Storage and Google Cloud Storage. And these platforms, even though they are so fundamental and so basic, they are not interoperable, meaning that the way that you integrate with those services are extremely different, extremely specific. The API calls themselves are different because Amazon, Azure, and GCP did not create a standard in which you could create a generic storage bucket, but also there are fundamental security concepts that differ between those providers, even if the API calls were standardized. Now, a lot of you might be familiar with the CIS benchmarks, the benchmarks from the Center for Internet Security, which gives you step-by-step instructions to harden infrastructure. Now, does the CIS benchmarks have a single cloud benchmark? No, they have the Amazon Web Services benchmark, the Azure benchmark, and the Google Cloud Platform benchmark. And if they were consistent platforms, we would only need one benchmark. Instead, the benchmarks are highly specific, and therefore our corresponding Terraform code will have to be highly specific. Because underneath the hood, Terraform has different providers, and these Terraform providers map to cloud providers or map to other types of service providers. And these Terraform providers call the specific APIs that are necessary in order to provision infrastructure and initialize the corresponding services. Now, in order to create infrastructure that is consistently secure in Terraform, that means that Terraform users must understand not only the conceptual differences between the different cloud providers, they also have to understand the different syntax that is used in Terraform for each of those Terraform providers. So that hypothetical code that we showed in the previous slide, here's what it would actually look like. 3 different sets of services, potentially different resources for the same service, and they would look highly different. So if we wanted to make a bucket that is completely private in AWS S3, traditionally, and I'll explain what has changed in that area in just a moment, we would need to create an S3 bucket resource, and we would have to create a bucket public access block. Now, in Azure, that does not map perfectly because we have a completely different concept called a storage account. And in fact, in Azure, there are 3 levels of hierarchy to storage. AWS just has buckets and objects. In Amazon, we have storage accounts. Within storage accounts, we have containers. And within containers, we have blobs, objects. So here, in order to create a private bucket, I guess the comparison would be an Azure container, we would need to create a storage account that prevents individuals from creating public containers within it, like so on line 15. And then for the storage container, we would have to specify that this is a private container and not one that allows us to access the underlying blobs or list the contents of the entire container. And then in Google, we have a completely separate resource in which we have to enforce uniform bucket level access, because in Google, you have the ability to specify different permissions for different objects, or you can make them uniform so that the entire thing is either public or the entire thing is private. Now, this gets even more complicated as we get into the more complicated services. So one of the key topics that we talk about in Sec 510 is cloud identity and access management. And cloud IAM is probably the most important subject in all of the cloud, because the same network controls that we have on-prem, they're still useful, but not nearly as useful as IAM controls are in the cloud. And the network capabilities cannot save us from, for example, a public S3 bucket necessarily. So IAM allows us to limit access from entities to different managed services. And this can be accomplished for users, so individual identities like human beings, or other infrastructure. So let's say your application needs to talk to an AWS resource, we would give it IAM credentials using what's called an instance profile. So here is what that workflow looks like. Your virtual machine has a set of credentials through what is called the instance metadata service. And using those credentials, the application is able to sign a request to a service like DynamoDB, and then DynamoDB is going to consult the IAM service, asking a very specific question. Does this principal have permission to perform this action on this resource? So it defines who is able to do what on what resources. Then the IAM service is either going to say, yes, you're allowed to perform this operation, or no, you're not, and therefore we're just going to send you an error as opposed to the details of that resource. Now, when you look at AWS's IAM Logic Flow, you don't have to read the specifics on this slide, but the goal of this slide is to kind of overwhelm you and show you how there is so much that you have to do in AWS IAM. You have the organization level controls called service control policies. You have policies that exist on specific resources, resource-based policies. You have IAM policies that are on individual identities, like a user or a piece of infrastructure. You have permissions boundaries that define the maximum permissions that any entity can have, or a specific entity can have, I should say. And then we evaluate whether or not the statement allows your action or denies that action specifically. How do these concepts map to Azure and GCP? Well, it's not perfect. We can see that they have similar concepts, such as default deny is the default behavior, and then we can explicitly deny actions on top of that. But there aren't things that map perfectly to a service control policy or map perfectly to a permissions boundary, for example. And then in GCP, the same concept exists. In Azure and GCP, we don't have both identity-based policies and resource-based policies like AWS does, but we have a very simple workflow for Google Cloud Policy. Now, that's just one difference. There are so many other differences that exist in the different cloud providers, and we cover them in depth in Sec 510, Public Cloud Security, AWS, Azure, and GCP. But we also cover a lot of those items in a free poster that we have at sans.org/cloud, which is called Secure Service Configuration in AWS, Azure, and GCP. And I'd highly recommend that folks download this completely free poster after this event, because you'll see a lot of huge differences, both about the default configurations between the different cloud providers, as well as the different capabilities. So if you can understand how these differences are so extreme, you'll also understand how the Terraform code and the Terraform providers also have to be significantly different. Now, beyond just the technical matters, there's also a potential conflict of interest. So when you look at the revenue numbers for the different cloud providers, you're going to notice that they are significantly different. AWS, which was first to market, has $80 billion of revenue in 2022. And this number is likely to increase as more people adopt the cloud. Now, in comparison, the entire Microsoft Intelligent Cloud sector of Microsoft made $75.3 billion that year. And that includes not just Azure, but also services like GitHub. So it's safe to say that Azure generates significantly less income than AWS does. Finally, if you look at Google Cloud, that number is even more extreme. $26.28 billion sounds like a lot. It is a lot to a normal person, but in this particular space, it's relatively chump change. So one of the things that AWS does not want to allow for is cloud agnosticism. They really want, or at least I assume that they want, and I would want if I was in their position, they want vendor lock-in. Because if people can easily take their application and move it from AWS to another cloud provider, that means that it's very likely that people will choose to move around as they desire to get the best financial deal, to be able to use the cheapest services to solve the problem at hand, or to be able to explore a bunch of different options and services that are out there. Because even if you prefer AWS in general, I'm sure that you would find some services from Azure or GCP that you would like in comparison to the analogous services in AWS. So without vendor lock-in, you're going to have a lot of people trying to get the best out of all of those options, and that is bad for AWS financially. So there's very little incentive for them to actively support interoperability, but I believe that if there was a truly transformative technology that can prevent vendor lock-in from happening, I think cloud providers may even have an incentive to purposefully break those integrations. So here, for example, let's say we had this magic infrastructure abstraction library that worked for all of the cloud providers and worked perfectly for all of the cloud providers. Well, here's what the API call would look like in order to create a new bucket. And it has a lot of different headers with a lot of different specifications and a lot of different items in your XML. In this case, there's only one, but there'd be more for more complex buckets and for different objects. Now, if I was in AWS's position and I saw that this magic infrastructure abstraction library was threatening me, you know what I would do? I'd probably make a change like this. Say, you know what? Never mind. We don't use the casing on the previous slide. We use snake case. We're going to use underscores for all of our attributes going forward. Now that immediately breaks all of those integrations. And maybe that's not beneficial for Amazon in other areas, but it is beneficial in the case of avoiding vendor lock-in. And maybe another reason why they can get you, instead of using Terraform, to use something like their proprietary CloudFormation service. Now, it's not even just about on purpose breaking these providers. Sometimes they break the providers by accident. One example of this that was very frustrating to me is I was teaching Sec 510 recently, and Amazon had just rolled out this new default security setting for Amazon S3. So now when you create new buckets in S3, they are automatically going to block all access and block the usage of ACLs by default. You have to explicitly give people access to S3 or explicitly make S3 public in order to accomplish the goal of sharing your files. Now, that's great from the perspective of security. It's not great from the perspective of the Sec 510 lab environment, because in Sec 510, we give you an environment that is purposefully insecure so that you can learn how to attack it as well as defend it. Now, this is just one example of how the S3 changes that they make in the background, even when they advertise them, can result in things breaking. We were aware of this change. We knew that it was going to happen sometime in April, but we weren't sure about the specifics. And as a result, things started breaking. So Terraform has a lot of work cut out for them. The people that work on the individual providers have to constantly stay ahead of the game to make sure they are compatible with AWS's latest set of changes. Now, it's not just about infrastructure as code. It's also about your applications themselves. So if you want to use Terraform to create cloud-agnostic infrastructure, that's one thing. But it's a separate matter to create an application that actually works in a cloud agnostic fashion, because your application is going to integrate with multiple proprietary APIs from each cloud provider. And I'll give you an example of that during our demonstration portion. So in order for our application to be cloud agnostic, that means that one of the two things shown here have to be true. Either your application has no cloud-specific service integrations, meaning that it doesn't talk to S3, doesn't talk to DynamoDB, doesn't talk to those other cloud services, or we would have to rewrite the application multiple times in order to target the desired cloud services. Now, I think that both of these options are really bad ideas, because cloud services are oftentimes more secure than the services that you write in-house. If you don't work for a cloud provider, then that means that your core competency is probably not working on a generic storage service. What is AWS's common core competency? To work on things like S3 to enable you to use their services and to generate revenue. So as a result, they are significantly more invested in making that service secure than you are, because that would just be the cost of doing business to create your own in-house service. It's not actually your business proper. So by leveraging the cloud services, you could potentially increase your security posture. But additionally, rewriting your applications to use those services, but use those services consistently across your different cloud providers, that is arguably even worse, because that process is very error prone and will also take a lot of time to implement. I know this firsthand because the Sec 510 cloud environment also uses a lot of different cloud agnostic integrations. So what do we do about this? Well, I don't have a perfect solution for you, but I have some ideas. The first one is there are some tools out there that are actively trying to solve this problem, trying to actively make a truly cloud agnostic platform in which you define code that you can use to deploy analogous infrastructure and services. One example of this I just learned about just 2 weeks ago is Dapper.io. And this is a project that is sponsored by the Cloud Native Computing Foundation. And their goal is to do exactly that, kind of be like Terraform, but allow you to define infrastructure and then go from AWS to Azure to GCP without having specific configurations for each service. Now, I think that this is a great project, or at least a great concept. I haven't used it yet myself. But it's tough. We already explained the incredible barriers that they have in front of them. They have to support all of those different integrations, and they have to keep on top of those integrations in case they change, whether or not by accident or on purpose. Now, the other thing that I would recommend is, and this is pretty surprising for a lot of folks, I actually recommend against going multi-cloud on purpose. Organizations often become multi-cloud by choice or by chance. Some people say, let's go multi-cloud because this allows us to pick and choose the best services for the job. It allows us to reduce our spend, and it also can be useful for avoiding vendor lock-in in a way that we would be affected with business continuity and disaster recovery situations. For example, some organizations have such critical workloads that if there was an outage in S3, even a small outage, then that would affect them significantly. And if you don't believe that that would happen, back in 2017, I believe, S3 had a significant outage that caused major repercussions from a financial perspective. So a lot of people want to go multi-cloud for that reason. I don't agree with that approach. I think that a better solution is to try to go multi-region, because oftentimes people will create resources within a single region in AWS. So many organizations purely work in US East 1. They don't look at other regions. So I think, for the reasons that I mentioned earlier, that going multi-cloud could be more trouble than it's worth. Now, That doesn't mean that you're never going to be multi-cloud. There are some times in which you have to be multi-cloud by chance. For example, if your organization goes through a merger or acquisition, it's not going to be on the top of the mind of the people that are dealing with that merger or acquisition of what cloud provider is used by that organization. They're not saying, oh, they're an AWS shop and we're an Azure shop, and therefore we should not merge. That's not a top priority for those decision makers. So you will have times in which the cloud provider will be integrated into your organization by accident in a way. So understanding multi-cloud and making multi-cloud environments secure is incredibly important, and that's why we teach it here at SANS. But I would personally avoid going multi-cloud on purpose. Choosing to go multi-cloud, I think, can cause more trouble than it's worth. Now, if you want to go multi-cloud, I would say at minimum, you should choose to run different workloads in different cloud providers. Creating a single application that works on multiple cloud providers is incredibly difficult, incredibly error-prone, and may prevent your organization from using the cloud services that your cloud provider offers. So if you want to spread out your workloads across different cloud providers, go for it. But if you're trying to get one core application onto the 3 cloud providers so that you can fail over from one to the other, I think that that is misguided personally. So let's take a moment to explore this a little bit in the Sec 510 lab environment. So I'm going to change my screen share real quick. There we go. So here we have the Sec 510 lab environment. Now, for those who are a little bit intimidated by Terraform, even though you're interested in learning more, I want to let you know that in Sec 510, we heavily use Terraform, but we don't require you to know Terraform going in, and we also don't require you to write a single line of Terraform code, because our lab environment comes shipped with all of this Terraform infrastructure that you can deploy yourself using some very simple commands, and then you can play around with that environment, and we will show you the ways of hardening that environment using Terraform, but you don't have to write it yourself. That being said, we have some bonus challenges. And one of the most important bonus challenges, in my opinion, is we're going to show you how to write Terraform code from scratch if you decide that you want to do so. It's not a core lab, but it's something that you can participate in as a part of the event. So we give you step-by-step instructions on how to do so. So here I have an example solution, or the beginning of an example solution for one of those problems. Here we have our AWS provider, our Azure provider, our Google provider. We have specific versions that we've installed for this particular demonstration. They're not the same versions that are in the bonus challenges. So if you're watching this in order to get ahead in the Sec 510 lab environment bonus challenges, sorry. But here we have those different providers set up, and we have a resource group created for Azure because Azure puts all of its resources into groupings. And then here we have the code that we could use in order to deploy our infrastructure to the cloud. And in this case, that infrastructure is just a simple bucket. We have a bucket here to create an S3 object. We have an Azure storage account, an Azure storage container, a particular file with a particular set of text, a Google storage bucket, as well as an individual object. Now I'm going to go ahead and deploy that using Terraform apply. Very simple command, and it's going to create a Terraform plan that shows you all of the changes that it's going to make. So I have my Sec 510 lab environment deployed, but I don't have this bonus challenge deployed currently. So let's see it run. I know it's going to come through. There we go. Oh, I accidentally pressed enter twice, so it decided to exit once I got to the prompt about whether or not I want to perform these actions. So it's going to create this Terraform plan, as we can see here. It's going to show all of the changes we're going to make. And then the user is going to approve of these changes or reject these changes by typing in yes. So excuse me, my terminal is jumping around a little bit. So here I'm going to type in yes. And now it's going to auto-magically create these resources. Now, in reality, all it's doing is making simple API calls to AWS, Azure, and GCP. But for me, writing Terraform is so much easier than making those API calls manually or even making command line interface commands individually. Not to mention that it has the benefits of being able to go through code review as well as having a declarative language so that you can ensure that you're only creating things that don't already exist. So we're going to have this run for a second. We'll see that currently on my web consoles, I do not have any buckets in S3. I don't have the Cloud Wars storage account in Azure. I don't have the Cloud Wars bucket here in GCP. But when this completes, it looks like the S3, looks like everything's finished just now. So now if I refresh this, I will see that I have a new Terraform bucket here. When I refresh the page, we're going to see a Cloud Wars bucket in GCP, and we have this Cloud Wars storage account in Azure. Now, we're not going to go into a whole lot of depth about S3 security. I just want to emphasize that look at how many different configurations are involved for an S3 bucket. We have this properties section, which has bucket versioning, the default encryption, and you can see that even the encryption is highly specific to Amazon. Amazon allows you to use Amazon KMS, the key management service, or the built-in S3 encryption mechanism, as shown here. Those capabilities are not analogous in the other cloud providers. In fact, in Azure and GCP, your buckets have a storage service level encryption that cannot be turned off. So while AWS now encrypts files by default, in Azure and GCP, you cannot make files unencrypted in the first place. So when you look at all of these different settings, it becomes pretty clear that these settings cannot perfectly map to one another. There may be services that get it done well enough, but it's basically impossible to perfectly map these capabilities together. And the same thing is true as you look at the configuration for GCP. Now to the second problem that I mentioned earlier, the application level integration. So here I have the application that we run in the Sec 510 lab environment. It's called Nimbus Immutabile. It is a fictional healthcare company, and we have this nice little website with a variety of different components in there. We have a customer chat solution. We have the ability to log in. And we have various different versions, various different features that you're going to use in the different versions of the application. So this is my deployment of Lab 0 in Sec 510. So from minute 1 to minute done, you are going to have this awesome application in this multi-cloud infrastructure. So I have this running in 3 different environments. I have it running in GCP, running it in Azure, and running it in AWS. And these look identical, and they, in fact, do function identically. But when we download this file, for example, this asset file here, from the different environments, behind the scenes, these 3 files are coming from very different services. This is coming from S3, this is coming from Azure Storage, and this is coming from Google Cloud Storage behind the scenes. And downloading a file is incredibly easy in theory. But even then, you're going to see some cloud-specific code that we have in our environment. We have created a very, very basic abstraction library for AWS, Azure, and GCP. It allows us to get objects, use keys, and a variety of other relatively simple services, simple operations in order to support the capabilities that we need in our lab environment. But even then, the code that we write to integrate AWS to S3 is radically different than the analogous capability for downloading via Azure, and the capability of downloading via GCP is also quite different. So even though there may be solutions that try to abstract away the infrastructure, even if there are capabilities that abstract away the actual services and your application integrations, I would argue quite forcefully that those abstractions are going to be high level and probably not satisfy all of the different business needs of the people that are watching this session. So with that, let's go back to our slides for a small conclusion. So here are the references that I used in this webinar. And here are some additional resources that I'd recommend that you check out. So first of all, I did a related presentation at RSA conference just 2 weeks ago. This is available currently on demand for all RSA conference attendees. So if you were there and you participated in RSA conference 2023, you can watch this recording on demand. And hopefully one day RSA will post it publicly, at which point I will share it on my professional network in LinkedIn. And I would recommend, if you'd like to, you can connect with me or follow me on LinkedIn. I'll make sure to share this out to everybody once it goes live, if it ever goes live. Additionally, sans.org/cloud has a bunch of different resources you may want to take a look at. There's the Cloud Ace podcast, which is currently a 12-episode podcast located on Spotify, Apple Music, Google Cloud, Google Music, wherever you get your podcasts. And this is where I got to interview 15 very, very smart and skilled professionals in the cloud security realm. I'd love it if you could check that out. Again, it's a podcast available freely on those different cloud platforms. There's also a multi-cloud survey that Ken Hartman and I did last fall, which is very related to the subject, and that's also free for download. All of these are free for download. There is an ebook that we had from the past SANS Cloud Exchange event that talks a lot about the different cloud providers and how they differ and how they are similar. We have that poster that I mentioned earlier. We have a multi-cloud command line interface cheat sheet that teaches you how to integrate with these different cloud providers using different sets of commands because they are not analogous to one another. There's also the top 5 considerations for multi-cloud security, a blog post that I have out on the subject. I have this white paper on Firebase that is related to Google Cloud, and we also have a blog post about Azure-based network monitoring. Sec 510 is the course that a lot of this content comes from and the course that I've authored and teach. But that course is just one component of the amazing SANS Cloud Security curriculum roadmap. So if you have any questions about the curriculum writ large, I'd love to talk to you about it on LinkedIn. And this course specifically, Sec 510, fits into our various different cloud journeys. So depending on what profession you are in or what profession you'd like to be in, we have different courses that map to those different capabilities. So we have cloud security analyst, engineer, DevSecOps professional, detection and response individual, as well as cloud security architect. And as you'll see, Sec 510, our multi-cloud course, is featured in all of the different journeys except for detection and response. We cover detection and response very briefly in Sec 510 in terms of teaching you how to turn on those capabilities, but it is not the course that is right for you if your main and really primary focus is detection and response. You may want to take a look at 541 instead for that, or 588 and 509. But if you're wanting to learn about cloud configuration management, as well as the different multi-cloud environments, the different cloud providers and how they are different from one another, I would definitely check out Sec 510, regardless of what career you are in currently or where you want to go. And finally, just a quick testimonial section for Sec 510. Here are a couple of quotes that we have from different people that have taken the course in the past. And I've really enjoyed writing the course. I've really enjoyed teaching the course. and I'd love to work with you at a future SANS session. And with that, I'll open it up to Q&A.
We don't have any questions yet, but we do have a guest who has commented, quote, Sec 510 is highly recommended, exclamation point. Thank you very much for that, Brian.
Yes, Brian, thank you so much for that. And it was great having you in the class.
So without any other questions, Brandon, I think we are all done for the day.
All right, folks. Well, if there are no questions and no one has any last minute ones, you can check me out on LinkedIn under Brandon Evans at SANS. I also have a Twitter account, although I don't really use it that much, but you're welcome to follow me there as well. And here is my email with SANS. So if you have any questions about Sec 510, the cloud curriculum in general, or you want any additional resources related to this webcast, please don't be a stranger. Feel free to reach out.
Thank you all so much and enjoy the rest of your day.
Take care, folks. Happy Sec 510 Day.